Good morning, students. Am I audible clearly? Okay. So let us start with our chapter contents. So previously we started with the linear regression. Linear regression, it means that we are building a linear model for our given requirement. So based on that, we have studied, it means linear regression is the start. It means where we start designing our model. So model, it means that this is a mathematical relation which will give the relationship between the features so that we can predict something. Okay, predict something or calculate some value or take some outputs, etc. So here in the last part, it means in the last lecture we studied that why the linear models are required, because here this is the very first step, or this is the basic, or we can say the initial thing or initial way of or simplest way of designing the machine uh, learning models, we can say. So here input features, it means that based on some values we can give some input, that is features like some matrix values, some vector values. Just like yesterday, we studied the example of flower classification, where we have seen which can be the features for a flower. So similarly here, whenever we are building a model, so always the first way or simplest way we can say that is a linear model. A single, that is not square or square root form of the features. We use a plain form of the features. So it is not always necessary that we will be using multiple features or all the features simultaneously. It depends based on the requirement. So here linear model is having multiple variations. Multiple variations, these are rich, lasso and elastic net are there. So before that, let us see, revise the details of the linear regression. So linear regression, it means that here we are going to find out a line for the line which will cover the maximum data points. Okay, for example, if I'm having the multiple features, then some feature will be given on the x-axis, some features will be listed on the y-axis, and then we are trying to find out with respect to the x, what can be the value of y, and if so, then what can be the best line which will give me the maximum coverage of the points. Okay, so this actually I explained by using, to give an example, just like if I'm talking about this line, so I can say that here there are multiple ways. So out of that, the first one is ordinary list squares. So ordinary list square, that is the simplest form of the uh, linear regression, I can say. So I will show you the figure. Okay, last time actually I've taken lecture on the another machine, that's why I cannot show the figure. Just a wait. Wait a minute. So this is the figure last time we studied. So here, whenever I'm drawing the line, so I will choose a line which will have the list output, that is list squares. List square, it means that if here, whenever we are having the multiple points, okay, let me share you the complete screen. I hope you are able to revise what we have studied into the last lecture. So actually, so if consider here in the last lecture we studied that which line we are choosing. If consider right now there are multiple data points are there. Okay, for example, here I am having one point, here I am having one point. This is my y axis, this is my x axis. And with respect to the x and y, I have plotted the many data points. Okay, so here whenever we are choosing the linear regression, it means that here it can happen that I'm designing the equation for this line, or it might happen that I'm designing the equation for this line, that is actually straight line, or I'm designing the equation for this line or this line. Okay, so when we are talking about the line, it means that I'm talking that for some x value which is multiplied by the coefficient, and if I added the constant, so this will give me the value of 1. Okay, so this is the simplest form of the line. So it means that here x, a, c, these will decide what can be the y. So x is my one feature and y is also my another feature. So y is my predicted output. So based on that, if consider we are designing the equations for this line, so it is at all not mandatory that we should use only one feature. We can go for using the multiple features as well. Okay, so it means that here right now we are designing the equation which will be having the minimum square from the data points. So if consider right now I'm talking about this line. Okay, this is my line number 1, this is my line number 2, and this is my line number 3. So each of the lines can, it means not a single line can cover each and every data points. I wanted to find out the line which will cover the maximum data points. So for this purpose, what we will consider? We will consider that line which will have the minimum square distance between the data points. For example, this is one data point, this is another data point, another data point, and another data point. So within that, whenever I'm talking about the line, I will calculate the distance between these. That is, what is the difference between my exactly line point and data point. So here, when we talk about this, so it means that if this is my data point, I will calculate distance from this data point to the line. Similarly, if this is data point from this to this, so my data point can lie either on the left side or right side or upper or below, etc. anywhere. But I wanted to find out the line which will be having the minimum square for all the data points. Okay, if there are, okay, there are, consider that there are 100 data points are there. If there are 100 data points are there, and out of that I have designed the equations for 3 lines. Consider line 1 which is having the square, that is 50, that is distance between the points and squares. Next, another line 2 is there which is having a distance of 40, and another 3 line is there which is having a distance of 60. Okay, 60 values or 60 units we can say. So you might be thinking why we are calculating the square. Square कशासाठी calculate करायचा? Because here, so here I'm having the less value of the y. इथं माझ्याकडे y ची value कमी आहे आणि data point ची value जास्त आहे. At this point I'm having less value of the data point and more value of the line. Okay. So म्हणजे ज्या वेळेला मी ही लाईन गेस करते, and if consider my data point is here and my data point is here. Here I am having the data value greater than the line, and here I am having data value less than the line, and that's why here I may be having positive distance and here I am having the negative distance. So negative and positive, if I directly go for the adding, so this will reverse and this will not give me the exact value, and that's why in order to take the absolute value, it means that only the magnitude value, we take a square of these values. Just like if I'm having difference of 2 here, 2 square, And if this is having difference of consider 3 points, so 3 square minus 3 square, we are having the 9, and 2 square, I'm having the 4. It means square value is always positive, and that's why here whenever we are calculating the minimum distance, we always take a square values, and then we combine this, that is out of these we combine this and we'll calculate which is having the minimum value for the squares. So if this is the out of 3 lines, if this is showing the minimum square, it means that there is a minimum difference between these data points and line, and that's why we will prefer these line which will be having the minimum distance between the data points. Okay, and this is the simplest form of the linear regression, which is also called as a ordinary least squares. Least stands for the less, that is least lowest value, and squares, it means that we are taking the squares of these distances. So, and then we are taking the average. So you might be thinking, after calculating the square, what we are doing? Actually, we are calculating the mean squared error. Error म्हणजे की बाबा माझी लाईन तर ही आहे पण डेटा पॉइंट इथं आहे, मग त्या दोघांमधला जो डिफरन्स आहे that is given by the error. That is, my line is actually not in line with the existing value. So here, linear regression is the simplest and most classic linear method for the regression. Linear regression finds the parameters W and B that minimize the mean squared error between the predictions and true regression targets. Okay, so here, so prediction, it means that the line gives my predicted value and this will be my true value. Okay, the mean squared error is the sum of squared differences between the predictions and the true values. So linear regression has no parameter, which is a benefit, but it also has no way to control the model complexity. So here, linear regression doesn't have parameters. It means that I'm not using any other methodologies for this. Just like for the line, we are using ax plus c, etc. So other parameters, it means that just like calculating the square root, calculating the coefficient or attributes, that is not a here in case of linear regression. So this discrepancy between performance of the training set and test set is clear sign of overfitting. So this may lead to the overfitting, and therefore we should have the model which will control the complexity. Okay, so here this is an equation for this, that is calculating the mean squared error. So yi, it means that this is the data value. This is data value, and xi, it means that this is a value for the given x on the line. Okay, so here we calculate w and b, and based on that we design our equation. So this is a code for this linear regression, that is where we perform data set loading and then calculating the slope, that is and checking how much accuracy we can get. Now I will move to the next point, that is a ridge regression. So here, whatever the previous case is there, so it may lead to the overfitting, and that's why we are moving towards the another variation of the linear regression, that is a ridge regression. So ridge regression, this is another form of the linear model. So this uses the same structure of the formula. Okay, same structure of the formula. It means that this structure of the formula, that is, I'm having x feature, I'm having x0 feature, I'm having x1 feature up to p number of the features, p plus 1 features, and w0, w1. So these are the coefficients. And there is also value of b is there. Okay. So in ridge regression, though the coefficient w are chosen, so not only so that they can predict well on the training data, but also fit for the additional constraint. Okay. So here we also want the magnitude of coefficients to be small as possible, so that w should be able to close to the 0. So here, actually, main aim of ridge regression is that even though here in this equation, if we are having the p parameters, okay, माझ्याकडे p parameters आहेत, p number of the parameters आहेत. So I wanted to calculate y such that the minimum number of the features should affect on my y. Okay, so in case of least squared error, that is mean squared error, I'm using all the features. In this example, or in this case, all the features are used. But here, ridge is having the uh, intention that it should have the minimum number of the features on which the y is dependent. Consider that I'm having n features, so it doesn't expect that on the all the n features my model should be dependent. It expects that if I'm having a 10 parameters or 10 features, so it should depend on 6 features or 5 or 4, etc. It doesn't expect that all the 10 features should be used for each and every time. And that's why whenever we wanted to make this dependent on the few number of the features, so what I will do right now for the y, I'm having w0, okay, first multiplied by x0 plus w1 multiplied by x0, sorry, x1, another feature, another coefficient, w2 plus, sorry, x2 multiplied by this. And similarly, consider there are 10 features, so I will write this as a w9 multiplied by x9, okay, as we started from the 0. So here, the main purpose of ridge is that out of these 9, if consider that I'm trying to minimize the value of these coefficients, okay, if the value of these coefficient is reaching to the minimum level, it means that if consider the W2 is having the value like 0.9, okay, it means that this is only going to give me the value which is equivalent to the 0. Okay, so here I will say that this is equivalent to the nearly equal to 0, and hence x2, this parameter doesn't have any effect on my y. समजा x चा माझा कोएफिशियंट जर 0 झाला म्हणजे x फीचर असलं काय नसलं काय तरीही माझ्या मॉडेलची व्हॅल्यू येते, or I can predict the y. So it means that this x2 feature doesn't have any effect on my y or prediction, and hence I can say that this feature need not to be necessarily used into the parameter, need not to be used into the equation, and hence I can say that the y is dependent on the remaining 9 features, or y may be dependent on similarly if another 2 features also got removed, then I can say that y is dependent on the 7 to 8 features, etc. So okay, so that is the ridge regression. Clear with this? What is the mean by ridge regression? So I will read the theory now. So we also want the magnitude of coefficients to be too small as possible. That is, all the entries of W should be close to the 0. Okay, so here main is that it should be close to the 0. Intuitively, this means each feature should have as little effect on the output as possible. Okay, so it means that this should have the very little effect or very less effect, which translates to having the small slope. Okay, while still predicting well, it means that even though this is having the minimum effect, still we should be able to predict the values correctly. So this constraint is an example of called a regularization. Regularization. So for this purpose, we need such method of linear regression. So regularization means explicitly restricting our model to avoid overfitting. Okay, I wanted to avoid overfitting. Regularization, it means that if consider as per the training model, I'm suggesting this should be the graph. So regularization, it means that here overfitting, it means that this is showing a deviation from the existing or deviation from the existing graph. Variation म्हणजे training madla and actual madla values with a difference. So this will be called as overfitting. Yesterday only we studied this concept, but the regularization says that it should be able to go in line with the current training data, and hence this is called as a there is no overfitting. If there is no overfitting, then so there are multiple levels of regularization are there. So this one level is called as a L2 level, whereas last level is called as a level 1 regularization. So please take a minute, read these contents, and then we will start with the next variation of the regression. Please be patient with me. I'm using personal network because of which I'm facing frequent breakdown. So please don't leave the meet for next again half an hour. So this is a code for using a ridge regression. So here instead of previously we use the regression, linear regression. Right now we are using a ridge. So these are all the existing functions available into scikit-learn model. So but here we are including the ridge. That is for everything, that is lasso and elastic net also the packages libraries are available. So right now I don't have this training set, that's why I will not take the implementation. But whenever we are going for the classification remaining, that is remaining implementations, we will definitely go for implementing these contents. So here, now I'm talking about the alpha parameter. Alpha parameter, it means that here, whenever we are dealing with the coefficients like whenever we are designing the equation, etc. So here we are not passing any extra parameter. Okay, alpha, it means that even though if consider here, okay, let me show you the simplest equation.
Here, linear regression, I'm not passing any parameter, etc. So alpha, it means that whenever I'm designing the equation for my linear regression, here along with the W0 and X0, always there is a one more attribute, that is a alpha. Okay, so right now I will use a symbol only to denote the alpha. So by default, whenever we are in default writing the equation, this is always 1. But sometimes it is shown that if consider we are designing the model, समजा की असं होतं की म्हणजे मी ग्राफ ड्रॉ केला. ओके, I had drawn the graph, okay, but my expected values are different than that. Then if consider I'm having x, y, z equation in model, that model simply cannot give me the value. In that case, what I will do, what your existing parameters are there, I will try to perform other operations like multiplying, addition, and then I will check whether the given data set is exactly matching with my equation. म्हणजे मी असं काय करेन की बाबा म्हणजे माझ्याकडे x आहे, w आहे, or we consider that simply we decided that here I am having this curve किंवा एखादी लाईन आहे. ओके, मी ही लाईन घेतली. ओके, मग ज्यावेळेस मी एक्स आणि वायच्या व्हॅल्यू एखाद्या कोइफिशियंट सोबत देते त्यावेळेस मला हे आउटपुट मिळत नाही. माझं आउटपुट कुठेतरी दुसरीकडे असतं किंवा इथं असतं, काहीतरी म्हणजे चेंज असतो. बट in order to come to this value, what I will do, whatever existing equation is there, within that y ahe or x is there, I will try to multiply this or I will try to perform other operations on this x and will check whether I can go with the existing relation, existing line or the most appropriate line. Okay, म्हणजे मी काय करेन की माझी ही इक्वेशन आलेली आहे, म्हणजे माझा हा मॉडेल बिल्ड झालेला आहे, पण हा मॉडेल माझ्या एक्झिस्टिंग डेटा सेट पासून व्हॅरी करतो थोडासा. म्हणजे की माझी एक्स ची व्हॅल्यू 1 यायला पाहिजे होती, सॉरी वाय ची व्हॅल्यू 1 यायला पाहिजे होती, तर 2 येते. जिथं 2 यायला हवी होती तिथे 4 येते. Or wherever I wanted 3, here it is showing 6. Okay, so it means that here whenever we are designing this, here I can see that the predicted value of y is 1, but it is actually showing me 4. Okay, predicted value of y is 2, but it is showing me 8. Okay, predicted value of y is 3, but it is showing me 12. It means that here I'm changing. Here I can say that this value is multiple of y, this value is multiple of 2, and this value, sorry, multiple of 3. म्हणजे जो एक्झिस्टिंग माझा प्रेडिक्टेड जो काउंट आहे त्याच्यापेक्षा माझी ऍक्च्युअल व्हॅल्यू थोडीशी व्हॅरी करते. बट आय एम एबल टू फाइंड आउट द रिलेशन बिटवीन देम. म्हणजे मी समजा माझ्या वायची व्हॅल्यू जर 4 पट केली तर माझा ग्राफ अॅक्युरेसी माझी जास्त वाढते. ओके, अँड फॉर दिस पर्पज वी डिसाइड द coefficient which is called as a alpha. Okay, alpha, it means that this is a alpha parameter we can say, or supporting parameter we can say. So what this will do, whenever we are passing this alpha, mag माझा जो data है or whatever model I have built, whatever model I have built, within that if I'm passing the alpha as a coefficient, alpha coefficient we can say, then it is showing the maximum जनरलायझेशन और मॅक्सिमम रेग्युलरायझेशन. म्हणजे मॅक्सिमम डेटा माझा त्यावेळेस पास करतो. मग त्या केसमध्ये मी सांगू शकते की हे माझं सपोर्टिंग व्हेरिएबल आहे की ज्याच्यामुळे माझी इक्वेशन अॅक्युरेटली मला ट्रेनिंगचा डेटा पण देते, टेस्ट डेटा सोबत सुद्धा हे अॅक्युरेटली वर्क करतं. So here whenever we are designing the equation, alpha value can be varied. Right now by default alpha value is always 1, which doesn't affect either of the operations. Multiplication operations are not affected. But if we change alpha to 0.5 or 0.1 or multiple, that is 10, etc., and we'll check whether our graph is exactly in line with the training, that is expected value, and actual values, then we can say the alpha coefficient works properly. मग अशा कोएफिशियंटला आपण अल्फा म्हणू शकतो. Okay, so by using the coefficients also we can check whether our equation is exactly showing the required contents. Okay, so this will check whether alpha is equal to, previously this was example by using alpha equal to 10 value. It will check alpha equal to 0.1 value, and it will check out of these two which one is more suited or more accurate, and based on that it will decide which one value to be used. Okay, and here plotting of these values. So this is actually a slide, I can say, which you need to take a closure loop. Okay, so here same data points, that is x and y, whatever we are talking about, those are both are same, but here I'm taking the different values of the alpha. Okay, so here the red, these are the we can say the indications used. Please go through this figure and let me know what you are able to conclude from this figure. Okay, let it be wrong, but I expect that you should give me the correct you should analyze the graph, that is the meaning. You can observe the graph and let me know your response into the chat window. I will give you 2 minutes. Okay, I can see that no one is responding. Listen, whenever we are dealing with the data science, the main thing is that we should be able to observe the things. We should be able to read the contents of the graph and what it implies. Okay, so right now this is the graph which I'm showing to you. So here I can see that the linear regression is shown by the blue circle, that is blue dot we can say. So the yes, anybody would like to share anything or make this some conclusions? Okay, no. Let us resume. So again, the green circle triangle shows the ridge alpha. Uh, Ridge alpha whenever they do of 10, that is shown by a red triangle, and the blue dark color circle is shown by the alpha equal to 1. So here, whenever we wanted to show the much more closeness between the data points, then we can see that here, whenever we are using the linear regression, we can see that the blue dots are much more scattered over everywhere. I'm using the linear regression. The single line will not be able to cover all the data points or maximum data points, and I can see that it will give the difference much more. Okay, that is a least square difference. If we are calculating the deviation from the existing model, this will be much more. If I'm choosing the line here or somewhere here, it will cover the minimum number of the points. Okay, and distance also, we can say that the distance between this point and this point is also much more, and because of which least square, that advantage we will not get, even though if I draw line somewhere else, etc. So this will not be able to hold all the values closer together. But now when it comes to the blue square, we can say, so blue square also we can see that the values are much more scattered here. But as compared to the linear regression, this is having the much more accuracy, or accuracy, it means that if I'm drawing a line here, this will cover the much more points, and also the difference between the actual line, the mean square error will be the minimum value. That is, as compared to the linear regression, I have a less value here for the mean square error. Now let us talk about the ridge alpha, that is a green rectangle. Green rectangle also I can see that the values are much more scattered, and hence the model also will not give the more accuracy. But when it comes to the ridge alpha equal to 10, okay, so I can see, or you also can see that here, this line, wherever my x is there, that is coefficient magnitude 0 is there. If I'm drawing the line here, I can see that the maximum points are mostly covered. And here, whenever we are calculating the distance, that distance is also minimum as compared to the blue, green, and faint blue. Okay, it means that here, whenever I'm showing the ridge alpha equal to 10 value, then I can say that this will give me the model, or this will give me the value which is much more regularized as compared to the previous options. And hence, we can say that this will this model is best given by the ridge alpha equal to 10 value. Okay, so here coefficient index we are passing here, and the coefficient magnitude we are passing. And whenever we are changing the value of the alpha as compared to the ridge, and in terms of linear regression, we can see that ridge, this is giving the maximum regularization or generalization, and whenever there is alpha equal to 10 value, so this will give you the maximum or minimum overfitting. Okay, minimum overfitting we can see here. Okay, clear with this? Clear with this? Okay, let me go to the next point now. So next variation is regarding lasso. So here again, we cannot say that ridge is covering the maximum accuracy or etc. So here, as compared to particular this model, I can say that this is whenever ridge alpha equal to 10 is there, I can see the maximum regularization is there. But there are again cases of overfitting can be there. And for this purpose, to avoid this, we shift to the lasso. Okay. So this is an alternative for the ridge for regularizing linear regression, that is a lasso. As with the ridge regression, using lasso also restricts coefficient to be close to the zero. Okay. In case of ridge, we are having the purpose that the coefficient needs to be close to the zero so that we can nullify or we can ignore the effect of that feature. But here lasso recommends that we should use all the features, and this is having a different way, that is a L1 regularization it uses. So here whenever but here this recommends that, that is whenever we are using the L1 regularization, so here some coefficients exactly reach to the zero. Okay. So this means that some features are entirely ignored. It means not minimum effect. We completely wanted to ignore those effects. So this can be seen as a form of automatic feature selection, and having some coefficients be exactly zero often make model easier to interpret and can reveal the most important features of your model. So here we can directly build the relation instead of going close to the zero. So this will take, that is instead of having the minimum effect, this will simply give the coefficient as zero, and because of which this will give which are the features important between the given set of the features. So okay, actually for the Boston housing data set this was used. So whatever previously this example is there, this example was also given by based on that, but I will not cover that what is meant by this housing data set. It means that one area and from there the data is taken. So here we are having data like that is housing data is there. What is, okay, sorry. Here we are having data like how much area is there, what is coordinates for the position, what can be the price, etc. It means multiple features are there. And this is the implementation for lasso in terms of Python language. So here we are checking those summation wherever coefficient is not equal to 0. And here again alpha equal to 1 we have taken, that is by default here also the alpha equal to 1 will be there. So after lasso, there is one more variation is there, that is a elastic net. Okay, let me show you. I think my slide changes are there in the another set. That's why I will take this one. Here, elastic net regression. So here, elastic net, again, previously we have taken just like the form of ridge, where we are taking the coefficient nearly equal to 0. And in case of lasso, we are trying to ignore few of the features. In elastic net, so this we can choose ridge and lasso regression when we have enough information about the features. But it is difficult to choose one when data has too many features and variables. So in such cases, we can use elastic net regression, which is good at estimating correlations between the features. That is, for example, if I'm having ABCD up to year, that is consider I'm having 6 to 7 features are there. If consider I know the relation between B and E, then it means that if E is dependent on the B, then I will specify the equation which is only dependent on the B instead of E. Okay, it means that here dependency between the or correlation between the features is studied. Okay, the penalty function of elastic net regression is combination of both L1 and L2 regularizations, penalties from lasso and ridge respectively. That is, it combines both power of both the algorithms, ridge and lasso. And this is also having the cost given by this formula. So here, this is having the best least square followed by the lasso and ridge penalties with their respective alpha parameters 1 and 2. So here we will be having alpha parameter as 1 and this will be having the value 2. So this is the most optimum combination of alpha parameters which can be determined using cross validations. Okay, and this is regarding the elastic net. So here elastic net have a combination of all those values wherever we wanted to cover everything. That is, we wanted to take features with some alpha value and take other features with some another value, etc. So here we are taking the absolute value here, and again we are taking the square value here. So and here we are taking the square value as well for the least squares, etc. And then it will calculate the output or prediction y by using that formula. Okay, please go through this explanation. And please don't leave the meet for next 5 minutes. Let me take the attendance. Yes, any problem? Correct.